compute the residuals and the sum of squares SSE for the given set of data and linear model. The set of data is 1, 1, 2, 2, 3, 4, and the linear model is y equals 1.6x minus 1. The y-coordinate in the data set 1, 2, 4, these are called the observed value. And the residuals is the difference between the observed and the predicted value. So we would take the observed value minus the predicted value. But the predicted value is the y value that we compute using the model. And so for x equals 1, the predicted value, which we call y hat, is 1.6 times 1 minus 1. And we can use a calculator to compute this. We will get 0.6. For the second point, when x equals 2, y hat is 1.6 times x, but x is now 2, minus 1. And this is 2.2. And for the third point in the data set, x equals 3. The corresponding predicted value y hat is 1.6 times 3 minus 1. And this is 3.8. Now, these y values that we just computed, they are called the predicted value. To compute the residuals, we simply take the corresponding observed value minus the predicted value. In this case, the observed value for the first point 1, 1 is y equals 1 minus the predicted value for the corresponding x equals 1 is 0.6. And 1 minus 0.6 is 0.4. And this is the residual 1 for the first point. To compute the second residual, we would take y2, which is the y value from the second point. In this case, y equal 2 minus the corresponding y hat, which is 2.2. And 2 minus 2.2 is minus 0.2. And for the third point, the observed value is 4, not 3, because the observed value is the y value from the data set, minus, and the computed y value using the model is 3.8. 4 minus 3.8 is 0.2. And these are the three residuals that correspond to the three given points. To compute the sum of square or SSE, we simply take the residuals, each of the residuals, square them, and then add those squares. In this case, the first residual is 0.4, we squared it, plus the second residual is negative 0.2, we take the quantity, square this, and the third residual is 0.2, we square this. No need to use the parentheses if the number is positive. We compute that this is 0.24. The number SSE, in this case 0.24, tells us how accurate the model is. If we were given a different model with the same set of data sets, and with that new model, we compute a different SSE following these procedures. If we obtain a higher SSE, then comparing the two models, this model would be better, would be more accurate. Using a graphing calculator such as Desmos.com, we first add a table. We punch in the data when x equals 1, y equals 1. That is the first data point. When x equals 2, y equals 2. and the last data point when x equals 3, y equals 4. Now remember that these y values are called the observed values. The function given is 1.6x minus 1. With the graphing calculator such as Desmo.com, it is better to use function notation. So in this case, we would write f of x equals 1.6x minus 1 instead of y equals 1.6x minus 1. Now to evaluate the predicted value, we simply bring up the function f that we just used, and so f of when x equals 1, we see that the predicted value is 0.6. When x equals 2, the predicted value is the y value, which is f of 2, and we see that it is 2.2. And lastly, when x equals 3, the corresponding predicted value is f of 3, which is 3.8. Now, having the observed values and the predicted values, we can compute SSE. We do this by taking the difference between the observed and the predicted values, square them, and then add them up. For the first residual, the observed value is y equals 1 minus the predicted value, y equals 0.6, square the quantity, plus for the second residual, the observed value is y equal 2 minus the predicted value is 2.2, square the quantity, plus, and lastly, the residual is when the observed value is 4, not 3. This is the y value minus the predicted value 3.8. Square this. We obtain the sum of squares 0.24.